Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acid-catalyzed hydration of an internal alkyne, Markovnikov addition of water using HgSO4 dil. H2SO4 proceeds via Markovnikov's rule to give the more stable enol intermediate, which tautomerases to the ketone. For an unsymmetrical internal alkyne Ar1CCAr2, water adds such that the O attaches to the carbon bearing the more electron-rich, more stabilizing group, giving the enol that tautomerases to the ketone with C is equal to O on that carbon. Step 1. Identify the alkyne. The starting material is PHCC, 4-MeO-C6H4, an unsymmetrical diaryl alkyne. The two aryl groups are phenyl, PH, and paramethoxyphenyl, 4-MeO-C6H4. Step 2. Regoselectivity of water addition. The paramethoxyphenyl group is more electron-donating than phenyl due to the OCH3 group. In Markovnikov hydration, water, as O adds to the carbon that can better stabilize positive charge, or equivalently, the more electron-rich carbon is protonated activated. The OCH3 group donates electrons to its attached alkyne carbon, making it the one that receives the nucleophilic O. Thus O ends up on the carbon bearing the 4-methoxyphenyl group, giving the enol PHCH is equal to C, O-4-MeO-C6H4. Step 3. Tautomerization. The enol PHCH is equal to C, O-4-MeO-C6H4 tautomerases to the keto form PHCH2C is equal to O-4-MeO-C6H4, which is PHCH2Co-C6H4OCH3, para. Step 4. Match two options. This corresponds to option CPHCH2C is equal to O-C6H4OCH3, para. Why other options fail? Option A. PHCO-CH2C6H4OCH3 would arise if O added to the phenyl-bearing carbon anti-Markovnikov with respect to electron density, giving the less stable enol. This is the minor product. Option B. A secondary alcohol would require incomplete reaction or reduction, not simple hydration tautomerization. Option D. An alcohol product, PHCH2CH, or C6H4OCH3, would require hydrogenation, not acid hydration. Therefore, the correct answer is C. Therefore, the correct answer is option C.